Let me ask you something. When was the last time you died? No, don't look at me like that. I'm serious. Because if I told you that most of the atoms in your body right now were not there a year ago, you'd have to admit that the you from last year is gone, physically gone. And yet here you sit, thinking you're the same person. So which is it? Are you alive, or are you the ghost of someone who already vanished? By the end of this talk, I want you to see something that most people never think about. I want you to understand what physics actually says about dying, and I think you'll find it says something quite surprising. Not comforting in the way a preacher might comfort you, but surprising in the way that only the truth can be. Let's start with something simple. Let's start with a candle. You light a candle. The flame flickers. It burns for an hour, 2 hours, and then it goes out. Now, I ask you, where did the candle go? You might say, well, it melted. But that's not really an answer, is it? The wax is mostly gone. The wick is a little stub of char. Something happened to all that stuff. Where is it? Here's where it gets beautiful. The wax was made of long chains of carbon and hydrogen atoms. When the flame burned, those atoms didn't disappear. They couldn't. They combined with oxygen from the air and floated away as carbon dioxide and water vapor. Every single atom of that candle is still out there, right now, drifting around the room or out the window, mixing into the atmosphere. The candle is gone, yes, but not one atom of it has been destroyed. Not one. This is the first law of thermodynamics, and it is one of the most fundamental facts in all of physics. Energy cannot be created or destroyed. It can change form, it can move from one place to another, but the total amount, it stays exactly the same, always. Now, you might say, fine, Feynman, that's a nice trick with a candle. But what about me? What about a person? And this is where it gets really interesting. You are made of atoms, about 7 octillion of them, give or take. That's a 7 followed by 27 zeros. It's a number so large that if you tried to count them 1 per second, it would take you longer than the age of the universe. And those atoms, every single one of them, were here long before you were born, and every single one of them will be here long after you are gone. Let me put it another way. The carbon atoms in your muscles were once inside a star. Not poetically, not metaphorically, literally. The carbon in your body was forged in the nuclear furnace of a star that lived and died billions of years before the Earth even formed. Here's how that works. In the early universe, right after the Big Bang, there was almost nothing but hydrogen and a little helium. That's it. No carbon, no oxygen, no iron, no calcium, none of the stuff you're made of. So where did it come from? It came from stars. When a star like our sun burns, it's smashing hydrogen nuclei together to make helium. That's fusion.